Yep. Ine.
Yeah, we'll see.
Hey, how are you?
Hi, how are you? Fine, thanks. Is everybody in already?
Yes,
I will be
you're
fine.
late.
Hi.
Take a seat. Good. So, are you ready to start? Perfect. I'm always. So, hello everyone. My name is Uwe Rätz, and I would like to welcome you here at Swiss Re for our DevOps Meetup on Microservices, Kubernetes, and CI. So the session today we'll have two parts. So the first part, in the first part we will hear some interesting presentations from Frantisek and Peter, and in the second part it's basically your turn. We do an open space. You can come up with topics that you would like to discuss, and then you can just grab one of the flip charts, and whoever wants to join the group and discuss is free to join. We will also serve some drinks and snacks in the back, and so it's a very open atmosphere. You can grab a drink, join the discussion, and you can leave whenever you want. And that's basically the concept of today. And with this, I hand over to Frantisek. Thanks. I think you will need the mic.
Sure. Perfect.
for the
Some
slides.
kind of audio quality, or at least some audio. All right. So basically, hi, all of you. I think this one is going to be streamed, so we will have an opportunity to share with other guys and to provide it on demand later, or maybe you can promote it now. So what's DevOps Slovensko? That's my idea. Maybe half year ago, I started with such an idea to create DevOps community because of movement, which is simply going on now with infrastructure applications and stuff like that. So this is third one. We just discussed that with guys attended before. It started like a very, very small occasion with just a few people. Yeah, first one was like presenters were not there. So it was quite interesting start. But then it improved, and hopefully it will improve more and more on each occasion later. Because of course we plan to deliver more later. So in coming weeks or months. So my part was planned for 20 minutes, but I'm not sure whether I will manage it. So, yeah, okay. So I have slides. I have also some kind of hands-on recorded and also environments. So if you would like to touch on the technology, we can make some workshop kind of approach later. So we can go through Kubernetes itself, command line, some constructs of Kubernetes, and also some constructs taking care about availability, deployment of Kubernetes in regard of underlying infrastructure. So, okay, so microservices, that's a very important part of today, which Peter Dodok is going to deliver. So he will resume after my session with microservices focused demo or kind of theory and experience from real prototype he's making. So let's go for it. yeah, so my part is about kind of service. So my background is VMware. I'm trainer of VMware technologies. So who knows me from VMware? Anyone who is working with VMware? Who has experienced some exposure, hands-on? Okay, okay, okay. I'm more used for more people reacted on this question because I'm from infrastructure, more infrastructure-related kind of areas, and audiences. So, well, I'm going to talk about the infrastructure perspective, including Kubernetes, so some kind of complete approach. So, basically, what's visible nowadays is a kind of approach to make a development or deployment of applications faster. So we can see now, and we will definitely see more and much more of deployments of applications in different formats as we used to be. We used to be in a real world in past decade or two. So what we can see now as a trend is replatforming and repackaging of applications. So in case it is a perspective of developer, pure developer, or if it is more about kind of deployment of new services, microservices architectures into the production environments. So kind of cloud native approach, especially for new applications is the case. So we have multiple kind of use cases when we need some kind of container or some kind of package, which should be very fast, flexible, easy to deploy. And of course, on the other side, with day two operations, they are included as in a kind of solution. So those are multiple approaches there. Also from a perspective of VMware, we can see those trends, and let's say VMware is trying to approach it also from a perspective of portfolio of solutions, of open source projects. Yeah, so that basic one approach is runtime. So that means containerization, runtime, whether it's Docker or some Rocket or some other engine there. So most of customers or guys working in this space are maybe starting with a kind of Dockerized package, potentially with some private repository, image repository, in a very simple format, because of course for developer, container is nice format because it's faster, flexible, efficient, which is interesting when you compare with virtual machine, which is maybe more robust, and but still we have some real world. So most of the time it's combination. Of course, we have existing infrastructure monoliths, and we have also containerized container runtime there. Then, of course, when the customer or company or whoever, doesn't matter, is going into the more agile approach, tend to go for a next step later. Of course, it's not necessary to go like first step, second, another step, but typically it's like starting with pure, simple Docker container runtime, then going for a next step, which is container service or orchestration, scheduler. So yeah, typically it's about availability of runtimes across multiple physical nodes, because this one is typically on premise, like laptop, PC, or some simple infrastructure. This one is across hosts, so there is orchestration scheduler. Yeah. So another one is application, high level, which is application or platform as a service typically. So then there is completely solved solution, including runtime, including scheduler, but also complete networking and all software dependencies based on code, which is submitted into the platform as a service. Yeah, so then also this kind of level, which is platform as a service, or application level platform, tend to have a lot of services instantly consumable. Yeah, so there are quite a lot of things there which are useful. Also, quota, some kind of spaces. Yeah, so a lot of role-based approaches regarding access to that platform. So it's, let's say, complete black box for a developer to consume based on code which is submitted to the platform, and platform simply build completely the stack end to end. So from a perspective of company of VMware, there is solution on the first level, which is integrated into the vSphere, which is, let's say, well-known infrastructure as a service platform. Yeah, vSphere is major product solution for virtualization for close to, this year is 2 decades. Yeah, because VMware was founded in 1998. So 20 years, well known, especially in financial institutions, banks, so insurance companies, all across the verticals. vSphere, VMware virtualization is there. So based on that, we are integrated container runtime right into the existing vSphere environment. So from a perspective of operations, it's a very, very convenient way to consume or provide containers for developers. So they can monitor, they can collect logs, they can secure, they can simply use the existing knowledge to handle containers. So typically, we are talking about Docker runtime running on top of the vSphere, parallelly to virtual machine runtime of VMware on the same vSphere platform. Yeah, so that's first one. Another one is topic which is more interesting or most interesting for me today, because I'm going to focus on this one. So that's usage of Kubernetes, which is well known. So we will talk about this. So it's called Pivotal Container Service. So it's a kind of container as a service, yeah, CAS. And then platform as a service, from a perspective of company of VMware, it is most or closest to company or project of Cloud Foundry, company Pivotal, taking care about Cloud Foundry open source project, which is the platform as a service. So it's on the level when I will compare maybe to OpenShift. That's the level. Yeah, so kind of give me a code, and I will provide you complete end-to-end runtime, and including exposure to external users. Yeah, so here we are talking about multiple layers underneath. So we have infrastructure as a service, which is typically for those two on-premise and VMware hypervisor. And then there is another layer, which is taking care about availability, resiliency, scalability of Kubernetes, in the case of this one, Pivotal Container Service, or taking care about runtime inside of Cloud Foundry, yeah, which is the platform as a service black box. Yeah, so Bosch, we'll talk about Bosch layer a bit later. So this is kind of overview, when you can see that the first approach is Docker runtime. This one is Kubernetes using Docker runtime as an engine inside. And there is the highest platform as a service, where there are a lot of stuff provided by Pivotal or third-party companies providing Cloud Foundry, using Cloud Foundry open source. I would say one important thing regarding this vSphere integrated containers, this is downloadable on a GitHub open source project, so you can use it you can download it immediately and run it on existing vSphere testing or production system, depend on use case, how you approach it. So this is available instantly. There is no constraint from VMware to limit you. That it's not possible to access documentation, binaries, or whatever. It's open source project. Benefit is that you can use it as a supported solution. So you can buy, or you can use it as as a complete solution, because vSphere, when the customer has vSphere board, this is included. Yeah, so the support is there, and you can just download. If you are okay without support, you can download and use it, no problem. Yeah, Pivotal Container Service, we will talk about this on the coming slides. Yeah, so generally approach is like, if you would like to have greater customization on your own, you are going down to the level of Docker itself or Kubernetes. If you would like to automate and leave it for a platform to process all that stuff, you are going for a more like platform as a service. So in this case, we are talking about Cloud Foundry. Now there is a rebranding of those things. So Pivotal rebranded Platform as a Service Cloud Foundry to something which is called Pivotal Application Service. So they are now crazy about services. Everything is service. Yeah? So Pivotal Container Service, Pivotal Application Service, Pivotal Function Service, which is kind of, let's say, most up-to-date thing. And it's serverless function as a service. I will talk about it on the last slide. Yeah, so that's a really, really interesting one. So Pivotal Container Service. Yeah, this is kind of a set of challenges we have with Kubernetes. Yeah, so yeah, well, availability, networking. Yeah, those are quite important things. Monitoring, security, of course. Yeah, so a lot of stuff. Yeah. And here is a set of layers. So what's here interesting is that all of those parts are now covered by some technology. Of course, it's not required every time to go only with this VMware hypervisor. You can go with other hypervisors. So we have solution for this. We just taking care about interconnecting multiple infrastructure as a service islands, and to use them as a complete solution, interconnected. Major one in this interconnection is SDN solution. Yeah? So in case of VMware is NSX SDN, software-defined networking solution. Yeah. Then there is a layer which is taking care about health, monitoring, healing, life cycle of Kubernetes itself. Kubernetes is taking care about pods, runtime, availability of pods. So that's one part, but we are taking care about availability of complete solutions. So for example, when master is going down, yeah? Or you would like to scale masters or workers. Yeah? So this is something which is solved completely end-to-end inside of this approach. And that magic thing there, which is taking care about resiliency, reliability of Kubernetes, is BOSH. And BOSH is core functionality of pivotal solutions of platform as a service, yeah, Cloud Foundry. So now we have some magic stuff there, which is used from this platform as a service and is joined with Kubernetes itself. Yeah, so yeah, another component here is vSAN, which is the storage. Of course, we can use also Fiber Channel, we can use iSCSI, we can use any kind of storage repository which is detected, in this case, in vSphere. So if you have existing vSphere, you have existing Fiber Channel, you have existing iSCSI NFS, you have potentially software-defined storage, which is in case of VMware vSAN. then you can consume all of them right out of the box, right instantly, right without any kind of special procedures, tuning, workarounding or whatever. Yeah, so there is plugin, storage container plugin, which is produced by VMware guys for open source consumption for vSphere. Yeah, so the same, we have a plugin for NSX. So yeah, one thing which I haven't covered is something like image repository. Yeah, so which is thing you should use in a real production environment. I mean, not playing with stuff, which is nice, but just, you know, deployed in a real environment into the production of enterprise use case. So then you need secured solution to store, scan image repositories or Docker images. Yeah? So that's something which you should think about. And solution from the perspective of VMware developers is Project Harbor. Project Harbor is open source. Again, you can download right out of the box, deployable for solutions like PKS or for any kind of Kubernetes or any kind of Docker standalone deployment. So it's absolutely not hardly wired with VMware kind of, let's say, fork. It's not like that. You can use it for any Docker Kubernetes deployment. So it's a very, very nice and cute solution you should maybe explore for. Yeah. So yeah, we have much more stuff from VMware, which is taking care about automation monitoring for cloud-native application or for hybrid approach when you have virtual machines, when you have classic standard monoliths, but also on the other side you have Kubernetes, and you would like to monitor all of them. Yeah. So we have combination of those so-called virialize VMware stuff and Wavefront, which is the cloud-native application monitoring. Yeah, but it's optional. You know, it's not required to do that as a all-complete solution. It's not required to deploy all that stuff. You can pick and choose most convenient for you. So we are talking about, in case of Pivotal Container Service, we are talking about, let's say, some predictable performance of deployment of Kubernetes in multi-tenant flavor. So that's really, really key, the message here, that you can rely and you can do it predictably. Yeah, so what we are talking about is deployment, fast, reliable deployment of multiple Kubernetes clusters on demand. Yeah, we are using layer Bosch here. What's important, we are connecting it to Google. So Kubernetes is Google project, open source, and we are connected to service broker. So we are constantly checking for Google latest vanilla release of Kubernetes. Here is a Harbor container registry for image repositories and a lot of stuff around it for monitoring. Yeah. So day one, build, deploy. Day two, monitoring, scaling, resiliency in case of failure. Yeah, so rolling upgrades, of course. Yeah, so what's complete picture is like, yeah, day one deployment. So we have multiple parts there, but basically, what's going on there? First use case is like when master is down. So yeah, this is from a perspective of cluster of Kubernetes. When one node of master or worker is going down, there is a system of checking of master and slave or worker nodes of Kubernetes. And in case the machine, in our case, virtual machine, because every Kubernetes node will be, in our case, a virtual machine. If the machine is down, there is in each of those, there is agent. and if there is detection that if that one is down, it's going to restart. So there is definition that okay, it should be as a desired state, like you know from Kubernetes itself. Inside, when you have pods, you have declaration that there is desired state to have 6 replicas of one pod. So this is similar, but on the higher level, from a perspective of availability of Kubernetes cluster as in master nodes and workers. So yeah, this is exactly the same what Kubernetes is doing inside. Bosch is doing on the level of taking care about Kubernetes cluster nodes. Yeah, so yeah, this is like scaling, multiple workers, yeah, scale. The first one was rebuilding of master, failed master. Patching, upgrading also, yeah. So there is a kind of automation in command line or automated kind of approach when you can simply instantiate upgrade procedure for every cluster, Kubernetes cluster you have there. So this is kind of nice solution when you have demand for fast deployment of multiple Kubernetes clusters in environment, telco operators, developer companies, you know, when you need to test a lot and you have a lot of changes. Yeah, so, and of course, at the end, there is a consumption of users against APIs of each Kubernetes. Yeah. So Bosch is designed originally from Google project Borg. Guys working on Borg, they just tuned it, and it was the basic layer then used in Pivotal Cloud Foundry project. Yeah. So yeah, this is deployment. So basically, deployment is every time taking care about you know, deployment into the vSphere in this case, where release or up-to-date release, new one release of Kubernetes is just packed and deployed via agent into every Kubernetes cluster. Yeah, and at the end you can see set of virtual machines. Yeah, so every pod or every Kubernetes node is a virtual machine. So deployment is OVA. Who knows this format? It's compressed format, yeah, of virtual machine. So we can download 2.5 gigs, and locally you will just import, or you can online import into the vSphere. So it's classic standard format of virtual machine deployments. So simple, one machine, one compressed format virtual machine deployed. Another one is then deployed as a PKS machine. So first one is so-called Ops Manager, which is from Cloud Foundry, kind of deployment tool. Yeah. So 2 virtual appliances there, and then you know, there is a Bosch virtual machine. So there is kind of a small footprint there for this one, and then command line PKS is going to be used for creation of Kubernetes clusters. Yeah. Important thing is there that we are integrated also on the level of networking, which is huge, because NSX, if you know NSX, maybe not, is originally open source project and later used by VMware for microsegmentation, software-defined networking, overlay kind of interconnection. Okay, so I will extend a little bit, 5 minutes, please. So yeah, that solution is of software-defined networking is implemented via plugin, and it's kind of listener. So it's listening on API calls against Kubernetes API gateway, and in case there is a new namespace in Kubernetes, it's automatically creating new overlay network, switching layer, and also router. All that stuff is automatically based on namespace, and you can automatically see structures in the management of NSX SDN software-defined networking. Plus, you can then interconnect in multiple platforms, vSphere and some kind of other hypervisors that are used. Yeah, so that's integrated also with OpenStack and stuff like that. Yeah, so you can use OpenSwitch on different platform and connect it to Kubernetes, for example, integrated or running on vSphere with one solution which is called NSXT. Yeah. So yeah, this is creation of cluster, and then kubectl creation of namespace. Based on namespace creation, team A, there is on-demand creation of logical switch C-class of network with router and overlay network automatically. Yeah. So this is something which is called microsegmentation, because you have on-demand automatic creation of segments, of course, with firewalling and rules applied automatically by default, by design. So there is no manual intervention later. There is by design automatic creation of policies as the namespace is created, or it's deleted later. Yeah, so this is security and networking completely integrating by design into the system of Kubernetes creation in CI pipelines or whatever. Yeah, so this is system working automatically behind the scenes. So you just create or delete it, just create all network, all firewall infrastructure. And if you don't need it, it will roll back and erase all set of security rules and network segments. So you can imagine in the real world, if you have to do this with firewalls, static rules, routing rules, stuff like that, it could be quite crazy stuff. So this is really, really robust, reliable infrastructure behind the scenes, and NSX is used also for vSphere data center enterprise solutions implementations. Yeah, so very, very strong proposition here. Yeah, so there are kind of rules there for access and load balancers included. So of course, software-based load balancing included there, automatically exposed for usage. Yeah, so this is really huge. Optimization of east-west routing, because we are taking care about this virtualized way. Yeah, so this is embedded in the hypervisor, taking care about efficient communication. So, okay, I will just jump this storage part. Maybe we can talk about this later. Harbor is important, guys. This is image repository I mentioned, including scanning. Yeah. So it's checking signatures, checking what's inside based on the definitions, security definitions. It's going to say, okay, this is valid, this is not valid. This is going to be used in pipeline or demand from developer. This is not valid because there are some threats. You have to take care about security inside. You have to rescan. You have to apply patches and then rescan again, and it will be signed and it will be used because it's safe. Yeah. In a kind of deployment. So this is procedure. Yeah, developer is using it. Is going to deploy it to Harbor. Exposure is there. Has to be addressed by security guy or our DevOps guy, and then it's allowed to be deployed to Kubernetes. Then on the layer of infrastructure, there is a BOSH. This is important. This is taking care about nodes of Kubernetes. Yeah. So 2 layers. This is image security, Harbor project, and then on the lower level, infrastructure level, BOSH is taking care about security and deployment of worker or master nodes of Kubernetes. So Uwe, please give me a second to show video, and I will finish. Yeah. So blah blah blah. Health check, lifecycle scaling, high availability, and integration of VMware, Pivotal, and Google. Yeah, so let's say quite nice combination, hopefully working. I hope that you will have the taste for it, and you would like to test it somehow later. Maybe today we have opportunity to go for hands-on labs. Yeah. So monitoring stuff, I will skip it. Yeah, we have a lot of stuff about operations, monitoring, let's say cloud native monitoring. So I will jump this. software as a service solution for monitoring. And I will show you just the deployment part, which is usable, of course, in command line, or this is GUI, but there is generation of process behind the scenes showing some parameters. What will be IP address, deployment, network connection, then usage for a command line. So there is a kind of credential which is also in command line, yeah, and you can just use it for a connection to Kubernetes cluster. Yeah, so it's a few minutes and you have Kubernetes cluster. Another one is how it looks from a perspective of virtual machines. Yeah, so this is Kubernetes node automatically created by PKS deployment solution, and here is a Bosch component command line taking care about masters and nodes of Kubernetes, so masters and workers. So this is one Kubernetes cluster created, yeah, by PKS before it was first created, and now we are going to check for status of masters and yeah, for that cluster. Yeah, so and now by purpose we are going to power off machines, so unexpected failure of master of Kubernetes. Yeah, which should initiate some kind of reaction of Bosch availability checking mechanism. Yeah, so now we will check whether there is kind of reaction or monitoring saying that okay, there is a problem. One member of Kubernetes is down. Yeah, so yeah, this is syntax of Bosch, and there is one master down. Yeah, so it's automatically detecting and starting reaction against the desired state of Kubernetes cluster. Yeah, so we should then see behind the scenes on the level of vSphere creation of new master, which is going to be there in a few seconds again for high availability, for availability which we would like to have. So I don't know, 3 masters or some number of nodes of Kubernetes cluster. Yeah, so deletion of all footprint of original one, and going to create a new one, and then later detected that status is okay by Bosch agent. Yeah, so yeah, it should be fine after a few seconds with full running state of all nodes. Okay. And there is a final one. I will make it shorter, which is monitoring, but I will make it much shorter. Yeah. So there are some running pods of Kubernetes, and this one is monitoring. So you can, of course, there are multiple choices of those kind of solutions. But microservices and Kubernetes tend to be very active. You are running a lot of systems because one YAML file is running a huge number of processes there. So you need some really real-time kind of monitoring. A lot of metrics there, so some kind of context should be there. So this is kind of one of options you can use, which is a Wavefront solution. Yeah, it's included in PKS solution. So, yeah. Maybe last one is function as a service. Recently, last week, 2 weeks ago, we had a guy from OpenFaaS, function as a service project. Now that guy is working for VMware. So we have project dispatch, which is taking care about multiple projects for function as a service, and yeah, all this stuff is amazing. Is of course downloadable from GitHub or VMware. You can play with that. Yeah, we can discuss also some workshop opportunities. There are all stuff is downloadable. I had the opportunity to be in contact with that guy, so we can do some workshop if you would like to have function as a service. We can do it. There is no problem. We have prepared content, so yeah, perfect opportunity to go step beyond classic Kubernetes. You can run, for example, open FaaS project on top of Kubernetes and run containers on demand on the level of per function, which is really, really efficient. Yeah. So, guys, that's it. Sorry for delay or for extension of time, which I had. Yeah.
For this presentation as
Yeah.
a service.
Thank you very much, guys.
If there are urgent questions, I think you can answer
Yeah.
it now.
Yeah.
Otherwise, I propose we have one topic for the open space, and you are still available. And if there are questions, we can discuss them also in a smaller group.
Yeah. So yeah, of course, I'm still here until 7 o'clock, so I'm available, and we can go through all of the resources. There is crazy a lot of stuff we can discuss. So yeah, perfect. Thank you. Takže teraz ja sa odopnem.
Ty sa odopni. Ty si odopnutý, ja sa zapnem. Ja som zapnutý. OK. So, hi all. My name is Peter Dodok. I'm software developer at Exeta SRO as a service. I try to focus on innovations and modern patterns of software development. And today I want to show you how we are developing our internal project with microservices in mind. Here is agenda. As an introduction, I will tell you something about our company and projects, and then in 5 major topics, I will show you some principles. And also I'm able to show you some cases on our demo application. I think that after session there will be more time to discuss about areas that you are interested in. Okay. Exeta is a German company with over 10 years history in software development and software consulting. We have over 700 employees, and also we spread across 10 locations in Germany, Switzerland, and Slovakia. There are 3 main industries we are focused on. It's automotive, financial services, and energy, with clients such as Deutsche Bank or Daimler Group or Red Bull. And Exeta made a decision to come here in Slovakia 2 years ago. And we started to think or started to transfer the knowledge from our German projects, which is mainly focused on microservices, and Kubernetes. We also decided to implement one cool, nice bank application to demonstrate this knowledge. Its name is Spending Report Application. The aim of the project is to build a web application for customers of the banks. Our intention is to use PSD to public interfaces to grab some data from these banks. Also, our implementation should be easy and should be easy to extend new solutions or new business opportunities. Okay, I will jump direct into spending report architecture. There is a web application written in AngularJS. There is 2 instances of this application. One instance is with dummy demo data located on file system, and second one is instance with a direct integration to API over gateway service. This concept enables us to develop both sides. How many of you are working with microservices? Few people, okay. So I'm going to touch the basic concepts. We have here spending report web, and the web is connected to support applications, which is gateway, and gateway is the main point where your API is published into internet. You are able to do here stuff like cross-cutting concerns, which means some security checks or some user tracking, user activity, and so on. There is also config service or config server. This principle is taken from Netflix. With config service, we are able to separate configuration of the application and code base. Next one is discovery service. Discovery service is service where you can find all your microservices and their IP addresses. Another layer is security. With OAuth implementation, we used OAuth 2 implementation. As orchestration or API level, we have one project, Spending Report API, and this project is connected to our core level microservices. Here in the diagram there is account service. This microservices is with DBS or database. I'm going to touch this microservice level in a few minutes. Last but not least is the integration services. It's a PSD2 bank services. This layer is not implemented yet in our application. It's planned in next phase. Okay, so what it means to have microservices. We have nice web application, and what it means to have it, or to have a backend services split into application. Main concept or basic strategy behind this is to use basic or main domain objects. This strategy is called bounded context. You can see 5 main domain objects, and with the strategy bounded context, you need to define the boundaries behind them, or boundaries among these domains, or let's say microservices. Okay. Let's have a look why we are choose microservices as a solution for our application. Let's imagine the monolithic application. There are big application with many requirements, resulting in a big code base in a repository. Sometimes JUnit or XUnit tests are skipped because of building takes too much time. There's a lot of dependencies and big classes, and context of tests are too big to create some such tests. Also, this all requires more people, more developers involved into process of development, and the cost of change is going to rise. On the other hand, with microservices, you have split the context of the application into smaller parts, and with these parts you have small application. Small application is driven with smaller teams. With smaller teams, you are able to use some agile methodologies, for example, Kanban, Scrum, and with agile methodology, your productivity goes up. Let's say about independent deployment. When you are changing something in monolithic application, and you want to deploy whole application as itself. With microservices, you need to deploy only the part of the application, and also it causes that when you have monolithic application and deploy whole application, you need to test this application. But with microservices, you need to test only the part of the application. Also, with microservices, there is better scalability. You can add more containers into the system when you want. Also, there is small scope of service, so when there is a bug, you directly locate it into microservices and improve fault isolation. My favorite is fifth point is technology or multiple technologies. You can use in microservices multiple technologies. For example, one microservice should be written in Java, other in C# or in Python. You can also use relation databases, and in case you need, you can use NoSQL databases. This is very flexible for me, I think. Okay, and I will touch the decreased risk level. With monolithic system, monolithic system is too big and too risky to deploy, and without testing, it's too risky. Okay, here there is a pipeline. Pipeline is divided into CI and CD pipeline, which means continuous integration and continuous deployment. In our project, we use GitLab CI tool, and this picture is grabbed from tutorial about GitLab CI, and I will show you this in our project. Let's talk about CI pipeline. You can see that first step of CI pipeline is to build. The main purpose to have this pipeline is to control our code. So when you push, or when developer push new change into repository, it should be built automatically, and it should be also tested automatically. Also, there is in this pipeline there should be integration tests. Our intention is to use smaller or small environment created with Docker Compose, and based on this Docker Compose environment we want to run some small or big integration tests written in SubUI. There is SubUI Maven plugin which run this test automatically. For this moment, we don't have implemented this integration test in our project because we have some issues with memory on GitLab runner. Next step is CD pipeline. CD pipeline is consists of review, staging, and production. Review means review of code during code merge request. Staging is deployment to staging environment, which means mirror of the production. And when the deployment and application is okay, you are able to deploy this into production there. So I can show you, if you want, the pipelines in our project, how it looks like. Here is a GitLab CI tool. Who knows this? Okay, perfect. Here is the section about CI/CD pipelines, and you can show here the stages of the pipeline. Here is the build stage, which means the building the code. Also, in this stage, we also have running JUnit tests. In the next step is release image. We after successfully built and tested the change, it will push new image into registry. And next step, after this second step, it should be running the integration test. We don't have yet. And here is the release new version. Release new version means to create new version of the project, which is able to deploy in some environments, and increase the version of a project in development. I will show you also here registry. Here is the registry with Docker images. We have for this project we have two images yet. It's 001, which is our production version, and master, which is our developer, which is our development version. Here is a nice point. I go to project code. Main file or pipeline is defined here as GitLab CI YML file. This file describes whole the pipeline, and you can see here there is the 3 stages: build, release image, and release new version. And also these stages have some jobs. You can have multiple jobs for one stage, but we have one for one. With build, we are doing Maven build, which means command Maven package. This Maven package runs compile and tests. After that, there is a job release Docker image, which means pushing or building and pushing the image into registry. Here is a nice thing. This variable, CI commit ref name. Here is stored the tag of the image. For example, when we are in development, here is the name of the branch. For example, master. During increasing the version or releasing the new version, here is the tag. For example, 001, as we saw. These 2 steps are done automatically. without any manually step. Last step is done manually. Here is the line which is responsible for it, and in this stage or in this job, we are doing release prepare and perform command in Maven. This will change version in POM XML file. It means that now we have 002 snapshot. With this running, it will be 002 release version, and next development version will be 003 snapshot. Okay. Also, here is a Docker compose file, which means which runs the images needed for running small environment for these microservices. You can see here that here is the database, and also here is the core customer service, which is this microservice. Okay. If there are any questions according to this, you can come to me after the presentation, and I will be glad to answer your questions. So let's jump into my presentation. Okay. Okay. What about testing? There is a question: which of these should be integrated into pipeline easily? I think that you know that first two is very simple to integrate into pipeline. Last one, end-to-end testing, is much more harder to integrate into pipeline, because there is some solutions, but when you face with maintaining this solution, it should be problem sometimes. Okay, Kubernetes. For us as developers, Kubernetes means that it's cluster environment. That's all I want to do from Kubernetes now. Let's jump into possible solutions. When you're dealing with Kubernetes, it's better first to jump into Minikube. It's used for your local development and learning the basic concept behind Kubernetes. Few weeks ago, we jumped into Amazon solutions for our project. We pick up COPS as integration with Amazon and Kubernetes. Also, there is Amazon EKS, but this project is in preview. As I can say that for me it's important to integrate this solution or this Kubernetes cluster into our pipeline. We run into problem that GitLab CI tool has some solution or has some integration with Kubernetes cluster, but it was only tested in Google Kubernetes Engine or in OpenShift. And when we try to run this integration against Amazon services, it will fail because there is some big stuff around rights and roles inside Amazon EC2. Also, our company worked on some solution for Kubernetes cluster on premise. It means inside infrastructure of our customers. Okay. Challenges you need to address with microservices. I pick up few of them. with rising or with adding more microservices into system, it increases the complexity of the system. You need to cope with this, and you need to have some monitoring or definitely monitoring behind them. Also, you can deal with performance problems because lots of communication is done via HTTP and also HTTPS. And you can solve this by some caching or some grouping the API services together. Big deal is transactions in microservices. There's always problem with transactions because when you spread transaction across multiple services, you can run into problem how to make a rollback, for example. And there is some strategies how to do it, but I can recommend that best strategy is to avoid transactions completely. Also, there is some minor problems or challenges, but interesting thing is to closer work with operation guys. I mean that we inside the team, we definitely need some guy from operation, because as a developer we don't have many concepts of production in our mind. What's next with our application spending report? We need to finish some microservices. Also, we need to configuring our AVS QI environment and integrate into our CI/CD pipeline to make auto-deploy into Kubernetes working. Nice thing is adoption of function as a service, as was said. It's a really interesting topic today or nowadays. And big deal should be also transformation from our internal project to real application published in the internet. Okay, here are some tips for you to self-study. I can recommend to have a look on this long and last one. This long is the integrations of microservices. It's from Christina Lin. It's a Red Hat. She is a Red Hat developer, and it is very nice stuff, and it's a very nice blog. And last one, it's a guide for Kubernetes. It's very funny because it was written with one developer as a request from his children his children ask him what is the Kubernetes, and he start to create some fairy tale for Kubernetes. It's very funny, and I recommend this. And it's finished. I thank you very much for your attention, and feel free to grab me here.
Thank you, Peter.
Share this feedback form or later? Then we will be just there, so it's okay?
Okay, then just press the button.
Okay. Like this? Yeah.
So we have prepared a feedback form for these two presentations and also the whole event.
And for upcoming sessions,
For
of
upcoming
course,
sessions.
as an input, because this is for real going to be used. So, and we will discuss later, but please feel it for us and for you to be used later, of course.
Or you can also leave your comments there on the whiteboard, and we will collect everything at the end.
Okay.
Good. So, are there any urgent questions for Peter? Does not seem to be the case. So I think we do the same as
Yeah.
for Frantisek. We have one topic about microservices maybe later for
Yeah.
for the group discussions.
Okay.
Good, thank you. So with this, I think we can close the first part of the session.
Yeah.
I think also some drinks and food are slowly arriving in the background.
Sounds good.
Sounds good, yeah. Now the second part really is really the open space approach. So I would like to ask you for topics that we discuss now in the group or in small groups.
Yeah.
Do you have any things you want to discuss?
Yeah, well, guys, be open, go for it. This is starting to be really serious, as I'm